You have seen that chaining and ranging are basic methods of finding out distances and relative positions of objects on the ground. Sometimes, though, you might find some obstacles on the ground which prevent you from carrying out ranging or chaining freely. So, how can you calculate distances and positions despite these obstacles? Let's find out the answer in this module, Obstacles in Chaining. Welcome. After completing this module, you will be able to solve the problems whenever obstacles occur in chain survey. Let's say you have to measure the horizontal distance between points A and B which are separated by this hill. These stations are not intervisible because the hill is the obstacle to ranging. Note that there is no obstacle to chaining as you can carry out stepping on the slopes of the hill. To overcome the hill as an obstacle, set stations C and D between A and B. Ranging between A and B is obstructed by the hill, but you can carry out stepping with the chain from A to the intermediate station C and from the intermediate station D to B. After that, add the horizontal distances of AC, CD and DB to obtain the distance between A and B. Now, take a look at the points M and N. There is a large rock between them, so ranging cannot be carried out. But you can run a chain along the horizontal from M towards N up to the point directly opposite N, which is O. After that, run the chain from N to O. In this way, you obtain a right-angled triangle MNO. As MN is the hypotenuse of the triangle, you can calculate its length with the formula MN is equal to under root MO square plus ON square. So, remember, when there is an obstacle to ranging but not chaining, you can use the chain for stepping or triangulation in order to overcome that obstacle. Now let's say you have to find the distance between 2 points A and B which are separated by a river. Here, the river is the obstacle to chaining but not to ranging. To find the distance between A and B, set a ranging rod each at A and B. Then, take a perpendicular offset at A to point C with the cross staff. Set a ranging rod at C. Then, with cross staff kept at A, extend AB up to D. Set a ranging rod at D. Then, set the cross staff at C and sight the ranging rod at B through the staff. Keeping the cross staff at C, take a perpendicular offset to BC up to E such that the ranging rod at E is on the line AD. In this way, you obtain two similar triangles, ABC and ACE. As the ratio between the sides of similar triangles is equal, we can say that AB by AC is equal to AC by AE. Therefore, we can say that AB, the distance between 2 points separated by a river, is equal to AC square by AE. So, remember, to overcome obstacles in chaining but not ranging between 2 points, first obtain two similar triangles. After that, calculate the distance between the 2 points by equating the ratio between corresponding sides of the similar triangles. Now let's say you have to find out the distance between 2 points A and B with a building between those points. Here, the building is the obstacle to both ranging and chaining. Note that the building is an upright structure, so it is impossible to set intermediate survey stations or run a chain along its surface. So, you can set the cross staff at A and mark a point C so that line AC is perpendicular to line AB. After that, set the cross staff at C and mark a point D so that line CD is perpendicular to line AC. Note that you should mark D at a place beyond both the obstacle and point B. Set the cross staff at point B and mark a point E on line CD so that line BE is perpendicular to line CD. Now you can see that AB is equal to CE. So, to know the distance between A and B, just measure the distance between C and E. So, remember, to overcome an obstacle to both chaining and ranging on a line, run two perpendicular lines of equal length, one before and one after the obstacle. After that, join those points and measure the length of the joining line. In this module, you have learnt how to solve the problems whenever obstacles occur in chain survey. To overcome obstacles to ranging but not chaining, you can use the chain for stepping or triangulation. To overcome obstacles to chaining but not ranging, first obtain two similar triangles. After that, calculate the distance by equating the ratio between the corresponding sides of the similar triangles. To overcome an obstacle to both chaining and ranging, mark points to get perpendicular lines before and after the obstacle. After that, join those points and measure the length of the joining line.